Now let's see how to find extrema on a closed interval. There are a couple of steps you're going to want to follow. The first thing you need to do is to find the critical numbers. So remember, to find the critical numbers, you take the first derivative and you set it equal to 0 or find where it does not exist. You evaluate f at each of the critical points, and then you evaluate at the endpoints. You just make a chart. Whichever value is the smallest is the minimum, whichever value is the greatest is the maximum. So let's look at an example. Suppose we're trying to find the extrema of 3x to the fourth minus 4x cubed on a closed interval minus 1 to 2. First thing you need to do is find the critical points. So f prime of x is 12x cubed minus 12x squared. Now you need to set this equal to 0. So f prime of x equals 0. Let's see, I'm going to want to factor this up here. Pull out the x squared because it's easier to see. X minus 1. All right, f prime of x equals 0 when 12x squared equals 0, or x equals 0, or when x minus 1 equals 0, or x equals 1. So I've found my two critical points. All right. So I'm going to write these down here. One critical number is 0, one critical number is 1. So now I need to evaluate my function at these critical numbers. Now, f of 0 is 0, and f of 1 is negative 1. The next thing I need to do is evaluate at my left and right endpoint. My left endpoint is negative 1, and my right endpoint is 2. So my function evaluated at negative 1 is equal to 7, and my function evaluated at 2 is 16. So now it's just a matter of selecting the largest and the smallest. The largest number here is 16. So f of 2 equals 16 is my maximum. And my smallest number is right here. F of 1 is my minimum. Now let's look at this one. This one's a little bit more interesting. 2x minus 3x to the 2/3 on the closed interval minus 1 to 3. So the first thing you need to do, of course, is take your derivative. So y prime is equal to 2 minus 3x to the minus 1/3 times 2/3. Forgot to multiply by that. So this is 2 minus 2 over x to the 1/3. Now, there's a trick here. You don't want to start dividing things out. What I want you to do at this point is to factor out anything in your denominator. So when I factor it out, I'm not going to lose any roots. So this becomes x to the 1/3 minus 1 when I factor it. All right. So now I can see where this equals 0. Y prime equals 0. Well, this first term can never equal 0. So it only equals 0 when x to the 1/3 minus 1 equals 0. So my only critical number is when x to the 1/3 is 1, or x is equal to 1. Excuse me. My only critical point is when the first derivative, my only critical point, because the first derivative equals 0, is at x equal 1. But there's another one, because y prime does not exist when x to the 1/3 is 0. So when x is 0. All right, so there are two critical numbers here. One where the first derivative is 0 and one where it doesn't exist. So I'm going to put my critical number here. And what is y at 0? Y at 0 is 0. And my critical number when x is 1 gives me a functional value. Y of 1 is equal to minus 1. So now I need to come in and I need to check my endpoints. My left endpoint is -1. So y of -1 is equal to -5. And the right endpoint is 3. Y of 3 is, well, this one's a little bit uglier. This is 6 minus 3 times the cubed root of 9. And that's about minus 0.2. So now let me pick my max and min. The largest number here is, wow, 0. So this right here is my maximum. And where's the minimum? The minimum is the smallest. That's going to be this one right here. Now let's look at f of x as 2 sine x minus cosine 2x. Again, we need to take the first derivative. So this is 2 cosine x minus 2 sine of 2x. Now, f prime equals 0, where? Well, the first thing I'm going to do is, I can't do this explicitly, so I'm going to use a trig identity. I know that sine of 2x is 2 cosine x, sine of x. Remember those? So I'm going to rewrite this. F prime is 2 cosine x plus 4 cosine x sine x. Now where does this equal 0? Remember, we're going to factor things out. So this is 2 times cosine. This is 1 plus 2 sine of x. Now we can see where this equals 0. Cosine of x equals 0 at pi over 2. And I've forgotten 3 pi over 2. And 1 plus 2 sine of x equals 0. When sine of x is minus 1/2, so when x is equal to 7 pi over 6 and 11 pi over 6. So these are kind of ugly looking, but that's okay. So now I need to look at my left endpoint, my right endpoint, and all of the critical numbers. And it turns out if I do this, the left endpoint is 0, and f of 0 is -1. At pi over 2, f of pi over 2 is 3. At 7 pi over 6, my value is minus 3/2. At 3 pi over 2, my value is -1. At 11 pi over 6, I'm at -3/2. And at my right endpoint, at 2 pi, I'm sitting at -1. So now let's select our max and mins. The largest number here is right here. So this is our max. Now this is interesting, because now let's look and find our smallest number. You're going to see we've got 2 of them. So these are both mins.